So I'll come back again, students. I'll start again for the purpose of the people who are recording. So the class is limits. Okay. Now the main two purposes of calculus is, first one, to find the tangent for a curve at a given point. Second one is to find out the area between curves. Now to find out the tangent, what is a tangent? Tangent is a point. So if there is a tangent is a line, is it not? To draw a line, you should need point plus slope, or we need 2 points, correct? So if I say a point on this curve, okay, so this point, only by having this point I cannot draw a tangent, is it not? I need a slope which is not given. Just by the equation of a curve being given, okay, a polynomial curve, I cannot find the slope at every point, is it not? I need another point here. So let me say x2, y2 is another point over here. Okay. Now if I draw a line here, what is this line? This line is called a secant. This line is called a secant. This line over here is called a tangent. Okay. Now if this x2, y2 is far off, okay, and x1, y1 is here, this is a secant. Now as this x2, y2 comes nearer and nearer, see, when it is over here, x3, y3, if this x3, y3 is over here, it approaches this tangent, observe. Now when you say here, it approaches this tangent, and then again here, tangent. So how close can you come? See, point doesn't have any any mass, it doesn't have an area, is it not? So between any 2 points I can put some other point here, okay. So when it is infinitesimally close, here you are having infinite points between any 2 points, okay. So you have that zooming feature in solid edge where you can zoom and you can see a point which is nearby. Also when you zoom it, it feels it is far off, is it not? So same thing happens here. So you are approaching a point here, you are approaching x2, y2 approaches x1, y1. So that approaching as a limit, we say, it doesn't go as one, it doesn't become x2, y2 doesn't attach with x1, y1. If there is x1, y1 and x2, y2 is the same, then what happens? It is 1 point only, you cannot draw a tangent. But it is close by, very very close by, then what happens? It approaches a tangent. Are you getting that point? That is one of the purpose of calculus. Now further when we go, slope can be written with differentiation, okay, and tangent or the slope is from differentiation we can go, and then area between curves can be done by integration, okay. That is the main purpose of calculus, differentiation and integration together, okay. Then you have differential equation, integral equation and all those things, that's extra, okay, but basics, okay. So now we will go with limits, okay, how the limits have to be understood. So what I have done is, I have told you what is a limit when you tend towards a point but it's not that point, okay. That is one way of going there. There is another way, okay. There are some places when you draw a curve, there are some places where the curve is not defined. There are cases where curve is not defined at a place. If I have x and y as the coordinates, you have a curve here, okay, but at a point somehow it is not defined, okay. So say this is x is equal to lambda, okay. So y is not defined at x is equal to lambda. Y is defined before x is equal to lambda, y is defined after x is equal to lambda. So the approximation of what would be y at x is equal to lambda is called limits. So what is limits? Limit, when you say limit, x tending to lambda, okay, y of x, okay, that this one, this is called, what would be the value of y, what would be the value of y when, or I'll say function of x, okay, limit function of x is y, it is y only but still, okay. So now as x tending to lambda, what would be the value of y, because initially f of x is not defined at lambda, okay. If f of x is undefined at lambda, then what would be that approximation, this x tending to lambda. Now this x tending to lambda can be in two fashion. One fashion is limit x tending to lambda minus. That means from minus I am approaching this, okay, f of x. Another one could be limit x tending to lambda plus f of x. Means I am approaching this lambda through positive x. Okay. Now,
Hello,
yeah, tell me.
sir. Could you repeat the part where you define the limits?
Yes. Limit is an approximation. Limit is an approximation of, generally it is undefined. Where it is undefined, it is an approximation of the value of the function. Okay, it is an approximation of the value of the function. Okay, whether it is defined or undefined, it is an approximation. Okay, what could be the answer? Which when we don't know, it is generally applied. If we know, it is the same thing. What we know is the approximation. Okay, but in case it is not defined, as we approach that point, as we approach towards that x is equal to lambda, what would be the approximate value of y? We are not worried about the actual value. Actual value we do not know because it is undefined initially. Because what happens, f of x may come such a way. For example, if I say f of x is, I'll give you this one. So if I say f of x is equal to say x square minus 2 divided by x minus 2, for example. Okay, I'm just putting it just like that. Okay, now you see when you say limit, okay, x tending to 2, okay, this value will go as 0 by 0. You observe this, and 0 by 0 is undefined, correct? So x, not x square, I'm sorry, x square minus 4, I can say x square minus 4. So when I do this, it is 0 by 0, which is undefined. So we have to use some other methods, is it not? What methods we will see later. Okay, so what we do when limit x tends to 2, what would be the value of this function, which is undefined actually, correct? If you reduce this to say x square minus 4 by x minus 2, we can always write this as x plus 2, is it not? Because x square minus 4 is x plus 2, x minus 2. But x plus 2 is not this function. This is an approximation. Then we say it is equal to 4. This is an approximation. But if you write the function in this fashion, it is undefined. Are you getting that point? This function is undefined. So even if it is undefined, because it is 0 by 0, even if it is undefined, at a point, the approximation at that point of that function is called the limit. Now, when you make an approximation, it has to be such that the limit when approached from the negative side as well as when it is approached from the positive side should be equal. If it is not equal, such limit does not exist. Okay, let me put it again. If limit x tending to lambda minus f of x is not equal to limit x tending to lambda plus f of x, then such limit does not exist. Does not exist. This kind of question come in GATE, where they give you and there is one option called does not exist D and E, which is a possibility in GATE. Keep that in mind. It's a possibility. Getting this D and E is a possibility. Okay. So when does it not exist? When x tending to lambda minus is not equal to x tending to lambda plus, then it does not exist. Is that clear, students? Any doubts still here? Very, very basics. It may so happen that there are some things like if you say, have you finished till here? Then I'll go with other things. Yeah, students, no doubts here? Write this down. Yes, students. Any doubts here? No? Please respond. Yes or no?
No, sir.
No. Fine. Okay. Next. Now, there are some possibility like you have, say, x, I'll go this way. Wait a minute. Let me see what is the thing I have got. Okay. I'll say limit, say, limit x tending to 2 magnitude of x minus 2 divided by x minus 2, if I have to define this. Okay, so now when you say magnitude, here what happens, I will tell you, I will explain this later on how to solve this. But in this function, what is going to happen is at 2, at the value of 2, okay, x is equal to 2, above this the value would be plus 1. Okay, this would be the curve. This is x, this is y. It would be, value would be plus 1, and below this, before 2, the value would be minus 1, and after this there is nothing here. Okay, so it will be minus 1. So it jumps from this point to this point at x is equal to 2. Because it jumps from that point, and the limit x tending to 2 minus x minus 2 magnitude divided by x minus 2 is not equal to limit x tending to 2 plus and x minus 2 divided by x minus 2. That is why limit does not exist. Very important, it does not exist. Okay, so you are going with from two sides. If it is not same, limit does not exist. Is that clear, students? Any doubts still here? Please respond. No or yes? Yeah, students. Doubt idea?
No, sir.
No, fine, very good. I want response. Okay. Anybody who has less noise in the background can respond to me. Okay. Noise of our fan is okay. Other than that, okay. Fine. Now let us go further. Okay. Now let us see how to solve limits problem generally. What are the various ways to solve limits problem? Here I am referring to Bosco as the book, because I was referring to that book when I was in my when I was studying 10th and 11th and 12th, that is PUC, first PUC and second PUC, I was doing that. So I refer to that generally. Okay, but I have put it in a proper fashion. That's it. I'm not going with the way Bosco goes, but I'm going with my own ways. But I will take problems from Bosco. So I will say some of these books you should not sell. So I have also not sold what I bought during 2000s. I have that with me now. Okay, so I'm using the 2000 edition book. Okay. So now whenever you have to do the limits, first way is to try substitution. Try substitution. If substitution works, very good, stop there. For example, let me give an example. Okay, example could be a simple one. Let me see what examples I can give. Okay, just a second, students. Okay, substituting is say f of x is equal to say x square minus 2 divided by 5. Simple one. Okay, limit x tending to 2, let me see, or limit x tending to say 3. Okay, if this is how it is given. Okay, x square minus 2 plus, I'll say x plus 3, like this. If this is given, try substitution directly. Always first step is to go for substitution. Okay, is substitution, during substitution, what is the answer I'm getting? 3, 9 minus 2 divided by 3 plus 3. So it is 7 by 6. Simple. You got the answer. Now there are cases while during substitution you will get the wrong answer. For example, if I say limit x tending to 2, limit x tending to 2, x square minus 4 divided by x minus 2. If I take this value, then what happens when you substitute? X square minus 4 is you will get it as 0, and this comes as 0. Now this does not mean limit does not exist. This is not the case. Don't get into think that this does not exist. It means that this is indeterminate. It means it is indeterminate. Means the function is not defined at that point. It is a hole there. It is not that limit is not defined. Get the difference between function not defined and limit not defined. Get the difference between this. Okay, if function is not defined, then we can try to define the value as a limit. If function is not defined, try to define the value as a limit. If limit is not defined, nothing can be done. It is not defined, it is not defined, that is, nothing can be done. Simple. Okay, if limit is not defined, nothing can be done. If function is not defined, try to define the value as a limit, the value of the function as a limit. Okay, now let us see this particular problem only. X square minus 4 x minus 2. Now first, try substitution has not worked. Okay, substitution has not worked. What is the next step we can do? Next step, if you are failing with substitution, is factorization. Factorize. Okay, if you cannot substitute, factorize. Step by step I am telling you. Okay, for example, here itself we have limit x tending to 2 x square minus 4 divided by x minus 2. Here I can factorize this. What I can do, I can say limit x tending to 2, I can say this as x plus 2 x minus 2 divided by x minus 2. So here, while factorizing, I will get something cancelled. So what I will get? I will get limit x tending to 2 x plus 2. The answer would be actually equal to 4. So if substitution does not work, next step is factorization. I hope you get that, students. Okay, so this is how you have to go. Okay, first step substitution, second step factorization. So let us see, in factorization we will see another problem here. Okay, the other problem would be, say, try to solve this problem. Solve limit x tending to 3 x square minus 2x minus 3 divided by x square minus 9. Now here let us substitute first. What is the first step? Step 1, or first try, substitute and see whether we can get the answer. So we will say, we will substitute. So substitute. Okay, when you substitute, we will get this as, this value will get as 3 square minus 2 into 3 minus 3 divided by 3 square minus 9. You will see 2 into 3 is 6, 6 minus 3 is 9, minus 6 minus 3 is 9, and this is 9, so this will become as 0, and this 3 square is 9, this is 0. So the value of the function is indeterminate. It does not mean limits does not exist. So first step, substitution, it has not worked. So next, factorization. So factorization is the next step. Factorize. So if you have to factorize this part. What would be the factorization? If you try it out, you will know that when you factorize this numerator, you will get this as x minus 3 and x plus 1. Okay, and below, x square minus 9 can be written as x plus 3 into x minus 3. Correct, students? So this answer here, x minus 3 and x minus 3 can get cancelled, and what remains is x plus 1 divided by x plus 3. Now what should happen? You substitute limit x tending to 3 x plus 1 x plus 3. Now this has reduced as approximation here. So here we have to substitute. When you substitute, what you will get? You will get 3 plus 1 is 4 and 3 plus 3 is 6. So this will become equal to 2 by 3. Easy, students? Any doubts here? First factorize, first substitute. If it doesn't work, it gives an indeterminate form. Then what you have to do? You have to factorize. Simple. Next, factorization does not work. Then what? Okay, let us do that. Okay. Now one more point. even if it is like this, see, there are some cases where it is direct. One substitution only you will get things. For example, if you have, say, limit x tending to 0 1 by x, you can't do anything with that. When x tending to 0, you cannot make it much more easier. So what happens? This is 1 by x is what? 1 by 0, correct? 1 by 0 is infinity, is indeterminate form, correct? You can say limit does not exist, or you can say infinity, one of the two. You can say infinity or does not exist, because infinity does not exist, is it not? Okay. Or if you say limit x tending to 0 1 by x raised to any n you have, okay, if you have x raised to n, then you cannot do anything, okay, it will go to infinity, okay, x tending to 0 x raised to n will go to infinity, okay. Or if you say limit x tending to 2, say square root of say like square root of x tending to 2, I can have this as 1 minus, say 1 minus x square. I have this x tending to 1 minus x square. What is this? This tends to what? 1 minus x square. You substitute 2, you will get this as 2 square is 4, you will get minus 3. So minus 3 is a complex value. So if it is a complex value, then also you can say it does not exist. Okay. So as a limit, complex values don't exist. That is not that's not imaginary numbers. Those are not real numbers. Correct. So it does not exist. Okay. Next point. If this doesn't work, then what is the third step? Third step is to find out. Sometimes what happens, it will be given in terms of fractions. I will see what type of fractions will it be given. Let me choose a problem here. Okay. Yeah, there is a good problem which is given here. Okay. Just a second, students. If it is given as a factor in case somewhere, okay, so if it is given as a factor also, you can do that. For example, if suppose you have such, last one is get a common denominator. Third type, okay, type 3 is to get a common denominator. Shift, okay, get a common denominator. Third one, get a common denominator. How are you going to get a common denominator? Let us see. For example, if I have, say, one function here is something like this. Just a second, students. Yeah. So let me have this as yes. Okay. Yeah, we will have it like this. Okay, limit x tending to 0 1 by x plus 5, okay, minus 1 by 5 divided by, say, x. This is a particular problem which is given. Now if this is given, see, you see, first step is to get the substitution. So let us do the substitution. So when you do the substitution, what I'll get is here x is 0, 1 by 5 minus 1 by 5, 0 by 0 you'll get. Next, factorization. It is not a polynomial generally, okay, so we cannot factorize. So get a common denominator. Common denominator may be x, okay. So now here what happens here in this case, actually it is simplification, okay. So common denominator is between these two. So you have to just simplify x tending to 0. I can say 5 into x plus 5, okay, divided by, say here it is what will come here, 5 minus x minus 5, correct. So my 5 gets cancelled and divided by x we have, okay. So this will become limit x tending to 0. You will have x here, so minus x divided by 5 into x minus 5, correct, into this x in the denominator x will come as, I'll say, into 1 by x, correct. So this x cancel, and what remains is limit x tending to 0 minus 1 divided by 5 into x minus 5, and the answer for this would be coming as minus 1 by 25. Is it clear, students? So this way also we can get a common denominator, try to simplify it. Okay, so when you simplify it gets, see actually limits are trivial problems. Okay, if you get it, it's very easy. If you don't get it, you will break your head and you will not get it. Okay, so it's very important that the easier ones we understand it properly, then everything else we can have. Another problem is rationalization. Fourth one is rationalization. Okay, fourth step is to rationalize. Sometimes there is a possibility that you may not get the answer, so you have to go with the rationalization. For example, if you have limit x tending to say 8, square root of x plus 1 minus 3 divided by x minus 8 is the problem. Okay, now how will you solve this? You have to rationalize. What is rationalization? You get the conjugate of this. So this can be written as into, okay, this will be equal to, I can say, this will be equal to limit x tending to 8, limit x tending to 8, limit x tending to 8. I can have this as square root of x plus 1 minus, first of all let us try substitution. Sometimes in substitution only we will get the answer. Now if you substitute here, you will get this as 8 minus 1, 8 plus 1, 9, square root of 9 minus 3 divided by x is 8 minus 8, right? So it is coming as 0 by 0. First check it out. Always there are various cases when substitution will give the answers. Okay, so don't have to do much. Okay, here minus 3 divided by x minus 8. We are going to rationalize the irrational ones. What are the irrational ones? Irrational ones are the one which cannot be written in the a by b form, correct? So square root is one of the irrational ones. So rationalization of the numerator, you can write it as x plus 1 plus 3 divided by square root of x plus 1 plus 3. Okay, now when you rationalize this, you get limit x tending to 8. Okay, here you can write it as x plus 1 minus 3 squared, that is 9, divided by x minus 8 into square root of x plus 1 plus 3. Clear, students? So now this can be written as, when you see this, you will get this as equal to, you can just hope that something will get cancelled out. So x minus, this will come as x minus 8, and below you will have x minus 8 into square root of x plus 1 plus 3. So you see this gets cancelled. So we get this as approximation as limit x tending to 8, 1 by square root of x plus 1 plus 3. So tell me the answer, students. It is root of 9, so it is be 1 by 6. Easy, students. Any doubts till now? Students, is there any doubts here?
No, sir.
Easy. So that is one of the ways you can do things. Okay. Next point is having a things like in the form of, say, that is the fourth point is over, right? What is the last point? Fourth point. Okay. So fifth point would be, if you have something in the form, this is something which has come in GATE a lot of times. Okay. So the fifth point would be in the form say sine x by x. If you have this form, if you have it in the form of sine x by x, then how to do it? For example, the rule, okay, I am doing this without proofs because proof is not required for this. It's a simple one, not a simple one, not that simple, but not required. What is required for GATE, only that we will do. Okay, so limit, say theta tending to 0, sine theta by theta is equal to 1. One of the main thing we have to do is we should not confuse 0 with infinity. For example, there is another rule which says limit theta tending to infinity, sine theta by theta is actually equal to 0. Okay, don't confuse this with this, very important. Okay, see whether it is 0 or whether it is infinity. So if it is sine x by x, if it is there, then what we have to do, like we can write this like this. Okay, so limit, okay, this is also another rule, you can take down this rule also. Both the rules we have to take it together. either limit theta tending to 0 sine theta by theta is equal to 1, or limit theta tending to infinity sine theta by theta is equal to 0. Both the things has to be understood. Okay, so if this kind of things comes, then what happens? Limit, say for example, let me solve a problem. Okay, problem 1. Okay, problem 1 is like this: limit x tending to 0 can we solve sine 2x by x. Can you tell me the answer for this? Now here we have to understand that limit of a b, okay, limit of a b can be written as, say, this limit of a b can be written as limit of a into limit of b. Very important, that has to be understood. Okay, limit whatever is in the denominator, that's okay. Okay, so that has to be understood. Now can we solve this? Now to solve this, what we have to do is we have to write limit x tending to 0. Here you see we have to be very careful that if it is 2x, below it should be 2x. So what we will do, we will multiply by 2 and divide by 2. Okay, and then we will say sine 2x and x. Now if you see 2x and sine x is 1. So the answer here would be 2, because limit of x tending to 0, 2 is actually equal to 2, correct? So this rule has to be satisfied here. So this is limit a into b, correct? So limit a into b is limit a into limit b. So limit a is 2. So let us write it 2 here. Okay. Then we have limit x tending to 0 sine 2x by 2x, which is equal to 1. So the answer is 2. Easy, students. So let us do another problem. So let us have this second problem. Okay, second problem solved. So I'll do it in the next slide. Here till now it's clear, students? No doubts? Have you written this down?
Yes, sir.
Stop me if you have not written, please. Okay, because I think it's easy, so I generally go fast here. Okay, second problem, let us see. Limit x tending to 0, solve. Just a second, Sumant is calling, maybe he is not able to get in. Hello Sumant. Video is lagging, is it? Okay. Okay. The video is lagging, is it, students? Is there a lag, students?
Yes, sir.
No. ಇಲ್ಲ ಮಾರೆ, ನಿಮ್ಮ ಸೈಡಲ್ಲಿ ಪ್ರಾಬ್ಲಮ್ ಉಂಟು. ಇರ್ಲಿ, ಪರವಾಗಿಲ್ಲ, ನೀನು ಕಂಟಿನ್ಯೂ ಮಾಡು. ಸ್ವಲ್ಪ ಲ್ಯಾಗ್ ಆದ್ರೆ ಪರವಾಗಿಲ್ಲ, ವಿಷಯ ಗೊತ್ತಾಗ್ತದೆ. ಅಲ್ಲ ಲ್ಯಾಗ್ ಆದ್ರೆ ಪರವಾಗಿಲ್ಲಪ್ಪ, ಅದು ಬರುತ್ತೆ ನಿನ್ಗೆ. ಯು ಆರ್ ನಾಟ್ ಏಬಲ್ ಟು ರೆಸ್ಪಾಂಡ್, ದಟ್ಸ್ ಇಟ್. ಓಕೆ, ಟುಮಾರೋ ವಿ ವಿಲ್ ಗೋ ವಿತ್, ಇನ್ನೊಮ್ಮೆ ನೋಡ್ಬೇಕಾದ್ರೆ ಯೂಟ್ಯೂಬ್ ಅಲ್ಲಿ ಹಾಕ್ತೇನೆ ನಾನು, ಅದ್ರೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ, ಆಯ್ತಾ? ಸೊ ಲ್ಯಾಗ್ ಆದ್ರೆ ಒಂದು 2 ನಿಮಿಷ ನಂತರ ಬರುತ್ತೆ ಅಷ್ಟೇ, ಏನು ವರಿ ಮಾಡಬೇಡ, ಆಯ್ತಾ? 2 ನಿಮಿಷ ನಂತರನೂ ಕ್ವಶನ್ ಕೇಳಿದ್ರೆ ನಾನು ಆನ್ಸರ್ ಮಾಡ್ತೇನೆ, ಆಯ್ತಾ? ಓಕೆ, ಸರಿ. See, this is one of the problem which comes in our online, but we have to do it because one of the things what happens is the people who wants to come for offline, they are allowed, there is no problem. Okay, you have both offline plus online, but online there is one additional thing that it will be put in YouTube, so you don't have to worry. If you miss something, it will be done. Okay, you will get the compensation of that. Okay, so but if it is lag from my side, it's a great thing. Okay, there should not be any lag from my side. I will try to see that from my side there is no trouble, but on your side if there is some lag, then I think some days some places the mobile connection will be slower, sometimes it will be faster, so that compensation will be done by your YouTube video. Okay, so now let us solve this problem. Sine 2x by 4x. Can you tell me the answer for this, students? Solve this and tell me the answer. Then third problem could be limit x tending to 0, say 7 sine 3x divided by sine 7x. Can you tell me the answer for this, students? Then fourth one can be limit x tending to 0 tan x by x Shall we solve all this problem? Second problem, you tell me the answer first. And also I am going fast, so there might be a lag, you might have seen more. Yes, student. Second one, what is the answer?
Sir, 1 by 2.
Very good. So answer is 1 by 2. Students got it? So limit x tending to 0, this would be 1 by 2 into sine 2x by 2. Sine 2x by 2x, that is equal to 1 by 2 is the answer. Is it clear? This one, what would be the answer here? So this would be limit x tending to 0. What will happen? You will have 7x by sine 7x, and then sine 3x by 3x into 3, correct? Because 3 and 3 should cancel, x and x should cancel. What should remain is 7 sine 3x divided by sine 7x. So this would be 1, this would be 1, so the answer is 3. Easy, students? Easy, no? Then tell me, what is this? Limit x tending to 0, tan x by x. How will you do that? You can do like this. Limit x tending to 0. What is tan x? Tan x
Sin
is
by cos.
sin x by cos x. I'll write x here, then I'll write
Cos
1 by
x.
cos x here. Simple. So sin x by x is 1, and this 1 by cos x. When you put x is equal to 0, cos 0 is 1, 1 by 1 is 1, so the answer is 1. Easy, students? So these are all easy things to be solved. Okay. Next, one more point. Okay. Another side we can have is limit at infinity. If the infinity is there and there is a rational function, how do we do that? Okay. Till here, is it clear, students? No doubts? I am going fast, I know that. It is fast because it is easy for you. That's what is my assumption is. Okay. For that reason, if I am going with the 11th standard student, then I will be slower. Okay, this is for the engineering pass out students, so I am a bit faster. Okay, but I can go slow also if you insist. If you ask questions, you can slow down anytime. Okay, so now let us see one more thing. Okay, let us see of the form, say limit, say this is, what is the point? 3, 4, 5. Okay, no, 5 is done, 6. Okay, so sixth one, if I have limit x tending to infinity or plus or minus infinity, if I say x is equal to plus or minus infinity, then we have numerator is a function of x, a polynomial of x, and denominator is a polynomial of x. Then how do we do it? Let us see. Let us see an example. Okay, so here first example, this has to be rational. Okay, so all the functions n and d has to be rational. There should not be square root and all those things. Irrational number cannot be there. Okay, so it has to be rational only then. Okay, if that is the case, first case let us see. Okay, that, see, when you say we will write this. Okay, n of x and d of x are polynomials of x. If that is the case, how do we do it? Now when you say polynomial, first case would be degrees. When you say polynomial, it will have degrees. How will be the polynomial? Polynomial can be written as say a1 x raised to n plus a2 x raised to n minus 1 plus a3 x raised to n minus 2 and so on. This is a polynomial, correct? So first case, in this case 1 I can say that degree of n of x would be lesser than degree of, this would be the case 1, degree of say denominator of x. That is, numerator degree is greater than denominator x degree. Then how to do it? For example, let us say a problem. Let us say 5x cube plus 2x square plus 3 divided by, say, denominator should be less, is it not? 2x square plus 3. Now how to find out the limits for this? Limit x tending to infinity. Now if you put infinity and infinity here, if you first is always substitution, when you substitute you will get infinity by infinity, which is not needed, right? So if this is the case, then what should we do? Okay, generally what happens is, how to solve this is, whichever is the biggest denominator, biggest what do you say, exponent, what we have to do is we have to divide each term by that exponent, okay, by that particular factor. For example, to solve this traditional, then I will tell you the shortcuts. First let us see how to solve this traditionally. Okay, cases, this can be set for case 1, case 2, case 3, all the 3 cases it's applicable. So here if this is the case, what we will do is, we will say x cube by x cube plus 2x square by x cube plus 3 by x cube. The limit is there, don't skip the limits. Limit x tending to infinity, okay, divided by 2x square by x cube plus 3 by x cube. So this is how you do it. So what you get here is 5 plus, here in this case you will get 2 by x plus 3 by x square divided by 2 by x plus 3 by x cube, right? This is also 3 by x cube. This is 3 by x cube. This is also 3 by x cube. Correct, students? So when you say, now you substitute the limits. Okay, so this is limit x tending to infinity. Now when you substitute the limit, you will see that 5, limit x tending to infinity, 5 doesn't have any this one, so it will be 5 plus 2 by x. When you put 2 by some large number, it will be 0 plus 2 by some large number, 0 here. Here it will be again 0 plus 0. So the answer for this is 5. This is how you do it. Easy, students? Is it clear? Okay. So here, am I correct here? Am I gone wrong somewhere? So here numerator, the numerator degree should be less than this. I will take out this case. I'm sorry here. So I'm just putting how to solve this problem. Okay. If this kind of things is there, this is how you have to solve. This is the direct method, students. Okay. After direct method, we will see case by case, one by one. Okay. Here what has happened is, degree of numerator is greater than what is there in denominator, but what I have written here was different. Okay, so cut that off. Okay, so this is how you get it, is equal to 5. Okay, now let us solve it. Okay, let us see case by cases. Okay, have you finished this, students? No doubts here? Any doubts, students, here? I am sorry, when I am hurrying there is some mistakes which are happening. Yeah, students, is that clear? Have you written this down? Understood?
Yes, sir.
Yes. There's no lag, is it not?
No.
Okay. Now, next point. Okay. Now, what is a shortcut to solve this problem? You have to see first case. Now, shortcuts we will say. Shortcut. Okay. If there's a shortcut, how to do it? Okay. Shortcut is like this. Okay. If you have limit x tending to infinity, for example, if first of all I'll say case 1. Okay, 1 second. So if you have case 1 is degree of numerator is lesser than degree of denominator, then what to do? Okay, that means I'll use one example. I'll say 4x square plus 3x plus 2 divided by x cube plus 5x plus 3. So this here, limit x tending to infinity. Now degree is bigger here, is it not? So here you said degree of numerator is less than degree of the denominator. If that is the case, now you have to understand this first, that when it is a large number, this is going as x square, this is going as x, and 2 is a small number, it is immaterial, so we will ignore these small things. This is a method. Okay, and here in this case, if you see, this has to be ignored. What is important is only the bigger terms. So x square by x, what generally it comes is here, limit x tending to infinity. You can write this as 4 by x, simple. So 4 by x, when you put x is equal to infinity, when you apply this will come as 0. So in general, limit of x tending to plus or minus infinity, it's not just plus, minus also is involved here, okay, whether it is plus or whether it is minus, limit x tending to plus or minus infinity. If we have say you say n of x, okay, divided by d of x will always be equal to 0 if degree of numerator is less than degree of denominator. Is that clear, students? How is it? Clear? Any doubts here? I'm going to go a bit slow now, okay, because otherwise you may not feel it comfortable, correct? Second case is degree of n equals degree of denominator. Then how to go it? Go for it. For example, let us say limit x tending to plus or minus infinity, say 3x cube plus 5x plus 2 divided by 2x cube plus 2. This is the question. Solving it becomes very difficult, is it? So what has to happen here is, you have to keep in mind that when you put limits, these things are immaterial. What is important is this and this only. So when you substitute infinity here, this and this cancels. So the answer directly would be the coefficients of the biggest degree. So the answer would be 3 by 2. Directly you can get it. Don't do anything else. Just directly put the answer 3 by 2. If it is same, put 3 by 2. This kind of things will be very handy for you in GATE, when it is important that you concentrate on speed. So when something is like this, just see, go slow, because even if you go slow, you will be solving this within half a minute. Okay, so 3x cube minus 5x plus 2, 2x cube minus 2. So it is 3 by 2. Direct, students, there is nothing has to be done. Okay, case 3 we will see. Have you written this down, students? So this will be coming as, when you have limit x tending to plus or minus infinity, n of x is equal to d of x would be equal to, say, ratio of leading coefficients. Ratio of leading coefficients when degree of numerator equals degree of denominator. Write this in as your in your formula sheet, students. Very important. Okay, done? Clear? Let me go further. Last one. Then we will go tomorrow. Okay. Last question. Last is like this. Okay. Now, if it was the other way around, then what? If you have, say, third case, degree of case 3, I will say here. Case 3 is degree of numerator would be greater than degree of denominator. Then what should be happening? Let us see. Example. Okay, I am really writing arbitrary examples here. Limit x tending to plus or minus infinity. I will say degree of numerator should be higher. So 3x cube plus 4x plus 1 divided by 2x square plus 4, we'll use some other number, 5x plus 2. Suppose this is the case. It's an immaterial, correct? What is important is these two. Now we have to see it. We have to correctly observe what is the way. Then only we can apply. Okay. So now in this particular case, when you solve this, what is important here? This x cube only, correct? So x cube and 2x cube. So when we do this, here we have to be very careful. What is it? Whether it is plus infinity or minus infinity. Very important. So this can be written as limit x tending to plus or minus infinity into, if you have 3x cube, this would be, what is important is only the bigger one, 3x cube divided by 2x square. So this will come as limit x tending to plus or minus infinity, extending to plus or minus infinity. You will have 3 by 2 x cube, sorry, 3 by 2 x. Now what is important is only x value. Now here this x value will be plus infinity if we have plus infinity, or minus infinity if this is x is positive. That means limit x tending to plus infinity 3x cube plus 4x plus 1 divided by 2x square plus 5x plus 2 is equal to plus infinity. And if you have limit x tending to infinity 3x cube plus 4x tending to minus infinity 3x cube plus 4x plus 1 divided by 2x square plus 5x plus 2 is equal to minus infinity. So here in this case 3, what happens is limit x tending to plus or minus infinity divided by into function of, numerator function divided by denominator function n of x divided by d of x would be equal to generally plus infinity or minus infinity, one of the two. It would be plus infinity or minus infinity depending on the degree of the biggest exponent, depending on the degree of the biggest exponent. That means if I had 3x power 4 divided by 2x power square, then what happens? I would have got x square. So it would be plus infinity whether I use limit till minus infinity or plus infinity. So it depends. Okay, so that is what we have done, students. Still more things are there in limits. Okay, one of the important thing what has to be there is L'Hopital rule. That also we will do. Most of the things what comes here is L'Hopital rule only. So today what I have done is very basics, and most of the problems can be solved using these basics. Okay students, thank you very much. Any doubts here? Any doubts, students?
No, sir.
Yes, thank you very much.
Thank you, sir.
Thank you.
Hello, sir.
Hello.
Sir, in that limit sine theta by theta, theta tends to 0.
Yes.
Sir, in that that problems are there, no? Like
These
that
one.
we has to expand, right? First one, second one, third one. Like limit sine 2 theta by sine 2x by 4x as x tends to 0.
Yes. That I've expanded. Yes.
So,
Correct.
okay, in a similar fashion, right?
Yes.
We
yes,
have to expand, right?
We have to expand, or we have to do some algebraic manipulation. That's it. It's not that always you
Then
have to expand. See, for example, here, what has happened? Sine 2x by x in the first problem. What we have done, we have multiplied and divided by 2. Is it not?
Yes, sir.
So like that.
Okay. Then we need to cancel.
Yes.
Simplify that.
Yes, simplify it. That's it. It depends. It depends on the problem.
Okay, sir.
Okay.
Thank you.
Thank you. Thank you.
Thank you.
I hope it has been easy for now, for you now. Is it not? Limits looks easy. Is it not?
Sir, practice.
No, it's easy only. It's not in GATE. All the problems are very easy. That has to be understood. Okay. Yeah.
Oh, sir. Okay, sir. Thank you.
Thank you very much. Yeah, Srivatsa, you had any doubts?
So in that, you have told traditional method, no, sir?
Yes.
In that, answer should be not defined, no, sir.
Which one? Which particular problem?
Next slide, sir. Next.
Next, this one.
Next slide.
Next slide.
Next slide. After that, sin x and also.
after the sin x. Okay, when you say infinity,
Yes, sir. Yes, sir. Previous slide.
see here one thing. It is the infinity is not generally defined. Okay, when you say
Okay.
infinity, it is not defined. Infinity is not a number. Correct.
Okay. Yes, sir.
So you can say not defined or you can say infinity. One of the two. Both are okay. But when
Okay, sir.
the infinity is given, you should not say do not exist, because they consider abstract number. Infinity is abstract number. If it is given, then fine. You can click that
Okay, sir.
infinity. Don't click do not exist. Okay. Yeah.
Okay, sir.
Thank
Sir, in the previous slide, sir, one more doubt I have, sir.
you. Yeah. Yes.
Previous one, sir.
This one.
Yes, sir. The answer should be not defined, sir. 5 by 0.
Correct. Okay. So here this is wrong, Baba. I'm sorry. Okay, this I'm not going to put on YouTube because it's not right. Okay. What happens here is it becomes 5 by 0, which goes to actually infinity, Baba. I'm sorry. 5 by 0 is actually infinity. The answer would be infinity. Okay. So I'll correct it
Okay.
tomorrow. It's a mistake from my side. Okay.
Okay, sir.
So this is 5x cube. Yes, this is infinity is the answer, not 0. Sorry here. Okay, this has to be correct. Okay. Yes.
Okay, sir.
I will correct it in tomorrow's class. Okay.
Okay, sir. Okay, sir. Thank you, sir.
Thank you.